Hi, everybody. Today we are going to learn about solving systems by substitution. In 4.1, we learned how to graph a system and find the solution, the point where they intersect. Today we're going to use some algebra, specifically using some substitution. All right, so let's get started. All right, so we're going to solve this system y equals 2x plus 4 and y equals 4x plus 6 by substitution. And we can see that in this top one, y is equal to this 2x plus 4. So we are going to substitute this into this second equation, and we're going to make one equation that's going to be equal to 2x plus 4. That's this part right here. And we know that has to be equal to 4x plus 6. All right, so we're going to solve this using our algebra skills. I'm going to solve for x, so I'm going to subtract 4x from both sides to start with. And now I have negative 2x plus 4 is equal to 6. Next, I can solve by subtracting 4 from both sides, and I get negative 2x equals 2. And you could probably see that we can divide by negative 2, and we get x equals negative 1. Okay, so this is just part of my solution because it's a coordinate on the graph that we're looking for. I need to plug this x in, and I'm going to find the y component that goes with it. So you can choose either equation. Choose the one that's the easiest. And if you can't tell which one's the easiest, just plug it into the top one. So I'm going to find y by plugging in 2 times negative 1, right? I'm substituting this x in right here. And I can tell that y is going to be equal to negative 2 plus 4. Y equals 2. All right, so I got the pieces for my answer, but now my answer is going to be negative 1, 2. I'm going to write it as a coordinate. All right, let's go ahead and work on this second example right here. We have this system, negative x minus 7y equals negative 21, and negative 5x plus y equals 3. You'll notice that we don't have a y isolated in either equation. So what we're going to do is we're going to take this second equation, and I'm going to get y by itself. I'm going to isolate y. And once I isolate y, I can substitute that into the top equation. So let's see how that works. So first, to isolate y, I'm going to add 5x to both sides. Okay, after I do that, I can see that I have y is equal to 5x plus 3. I'm going to take this 5x plus 3. I'm going to substitute it right here into this equation for y, and I'm going to make a new equation. So my new equation will be negative x minus 7. I'm going to open up some parentheses. That's going to be equal to negative 21. What I'm going to substitute in my parentheses is 5x plus 3. Okay, and I'm going to solve this for x. I'm going to be careful because this is a negative number right here. I'm going to distribute, and I have negative x minus 35x minus 21 equals negative 21. I'm going to combine like terms. Negative x, that's like negative 1x minus 35x. That will give me negative 36x minus 21 equals negative 21. Looks like it's going to be complicated, but look what's going to happen. I'm going to add 21 to both sides, and I could see that this will cancel out, and I have negative 36x equals 0. I'm going to divide both sides by negative 36. This will cancel out, and I have x equals 0. All right, so that's my x component. Now I'm going to substitute this. I could substitute it into the top equation, the bottom equation, or I changed around the bottom equation so I have y isolated. So it makes sense to plug it into this one right here. And let's do that. So I'm going to have y equals 5. I'm going to open up some parentheses, plus 3, and I'm going to substitute this 0 into my equation. All right, I have y equals 5 times 0 is 0 plus 3, and we know that 0 plus 3 is equal to 3. So my solution would be 0, 3. Right? These two lines would cross at the point 0, 3. Awesome. All right, let's work on some special cases here. This is going to be the second page. This is page 5 in our notes for this chapter. And we have y equals x plus 2 and x minus y equals 2. Let's use substitution. I'm going to take this, since I already isolated y, and I'm going to substitute it in here. And I'm going to make it a new equation. I'm going to have x minus, I'm going to open up some parentheses, and then this is going to equal 2, right? X minus whatever y is equal to equals 2. And I know that y is equal to x plus 2. And we know that there's like a phantom 1 right here, so I'm going to use that to distribute. And I'm going to solve for x. I would have x minus 2 equals 2. All right, so x minus x, that cancels out. And I get negative 2 is equal to 2. Since I have no more variables to solve for, I just have two unequal numbers that my equation says are equal to each other. That means there is no solution to this equation. All right, let's do one more. This is going to be another special case. We have 2x plus 3y equals 6, and y equals negative 2/3 x plus 2. So this one's in standard form, this one's in slope-intercept form, and this second equation is already has y isolated. So I'm going to take that and I'm going to substitute it in right here for y. And I'm going to make a new equation with just x variable. So I'm going to have 2x plus 3. I'm going to open up a nice big space in my parentheses, and this is going to be equal to 6. And what I'm going to substitute in here is negative 2/3 x plus 2. All right, this looks a little bit crazy to solve, but we can do it. So I'm going to take this 3 and I'm going to distribute. All right, once I do that, I have 2x. This is positive, this is negative, so it's going to be negative 3 times 2 is 6. Divided by 3 is 2. So it's going to be negative 2x. Let me show you again. 3 times 2 is 6. Divided by 3 is 2. So I get 2 right there. And then 3 times this positive 2, I got to remember to multiply by the second term. So 3 times 2 is 6, and this equals 6. Let's see what happens. So right away, I see that these cancel out. So kind of like the last example, but in this case, we get 6 is equal to 6, and that is true, and that is always true. And what that means is there are an infinite number of solutions. So we're going to write infinite solutions. And graphically, if we were to look at the graph of this system of equations, these would be the same line. Remember in our last section, we saw that the same line, when we graph two equations, they have the same line. We have an infinite number of solutions. All right, so that's it.